Welcome to AEL. Today, we are diving into one of the most essential components in electronics, the LED. What are LEDs? How do they work? Why do we use resistors with them? LED stands for light-emitting diode. It's a special kind of diode that emits light when current flows through it. Unlike a regular bulb, LEDs don't have filaments and don't generate much heat. They are energy efficient, small, and last a long time, making them ideal for modern electronics, from indicator lights to giant display boards. LEDs are polarized components, meaning they have a positive leg named anode and a negative leg named cathode, and they only work when connected in the right direction. If you reverse the connection, the LED simply won't light up. There are many types of LEDs. Here are the most common, standard 5mm LED. These are what you usually see in Arduino kits. High brightness LEDs, these shine much brighter and are used for lighting. SMD LEDs, these are surface mount LEDs, very small, used in compact designs like mobile phones and LED strips. RGB LEDs, these contain red, green, and blue LEDs in one package. You can mix colors to create nearly any shade. Infrared LEDs, these emit invisible infrared light, often used in remote controls. Bicolor and tricolor LEDs, they have multiple LEDs in one and can change color based on polarity or input. So, how do LEDs actually light up? When you apply a voltage in the correct direction, electrons flow through the LED. Inside, this movement of electrons releases energy in the form of light. This process is called electroluminescence. Each LED is made from different semiconductor materials, which determine the color of light it emits. Let's talk about connecting LEDs. Always remember, the longer leg is the anode, which is positive. The shorter leg is the cathode, which is negative. Or look for the flat side on the LED, that's the cathode. To connect an LED, you need a power source, like a battery or Arduino pin, and resistor in series with it. Never connect an LED directly to a power supply without a resistor. Why? Because LEDs are current-sensitive devices. Even a small increase in current can destroy them. Resistors limit the current that flows through the LED, protecting it from burning out. Without a resistor, the LED will draw as much current as the power supply can give, and that usually ends in smoke. What value of resistor should you use? Let's do some quick math. LEDs has forward voltage, typically 2 volt for yellow LEDs, and a safe operating current, usually about 20 milliamps or 0.02 amps. Let's say you're powering a yellow LED with a forward voltage of 2 volt with a 5 volt supply. Let us use Ohm's law to calculate the value of resistor. Resistance, R, equals supply voltage minus LED voltage, divide by current. So, the resistance is equals 150 ohms. That is the resistor value you need to safely limit the current when powering it with a 5 volt supply. So let's do a simple simulation. Connect the schematic on your Pro Tools as you see here. Notice we use a switch for demonstration, a 5 volt DC source, a 150 ohms resistor as we calculated, a yellow LED. We see it is the same with the circuit we use for our analysis except for the switch added. So, for us to visualize the voltage and current, we need to edit our schematic by adding an ammeter in series and voltmeter parallel to the LED and resistor. With all connected, click Simulation button. Nothing display because our switch is open. So, with the switch closed, we see the current and voltage across the LED and the resistor as calculated in our analysis. And that's your crash course on LEDs: what they are, how they work, and how to use them safely. If you found this helpful, don't forget to like, subscribe, and check out more tutorials on Alpha Electronic Lab. Keep experimenting and see you in the next video.